Alright, we're going to simplify a radical. You have to know what a radical is. It's just another name for a square root symbol. So when I say radical 36, that's what it looks like. It looks just like square root of 36. And I'm going to show you a pair of numbers that's in 36, because obviously we know the square root of 36 is 6. 6 times 6 is 36. So I just simplified this radical. It just becomes 6. Now I'm going to show you with a number that's not a perfect square, so you can see why I just went through the hard way of simplifying radical 36. Let's say we have the radical 24. So 24 is not a perfect square, but it does contain a perfect square. If you break down 24, you know it's 12 times 2. You know 12 is 6 times 2. And you know 6 is 3 times 2. Right here I see a pair of 2's, which means 2 times 2 is 4. There's our perfect square that is contained in 24. So that's going to come out. 2 times 2 is 4. Square root of 4 is 2. So that comes out as a whole number. We still have that 3 and that 2 inside that are not perfect squares. They aren't part of a perfect square. We're going to multiply them back together and keep them inside the radical. So square root of 4 is 2, and 6 is left over. And if you can recognize the perfect squares right away by looking at the number, you don't have to break down all the way to all the prime numbers. You could just say, oh, I know 24, and I'm going to kind of go up on this. I know 24 is 4 times 6. 4 is a perfect square. The square root of 4 is 2, and I've got the radical 6 left over. And you read this answer like that, 2 radical 6. So radical 24 simplifies to 2 radical 6. I'll do one more. Radical 50. I know that there's a perfect square in 50 because I know it breaks down to 25 times 2. So I could go right from here and say, okay, the square root of 25 is 5. And 2 stays under the radical. So radical 50 simplifies to 5 radical 2. If you didn't realize 25 is a perfect square, and obviously I'm talking about some number maybe that isn't as obvious, you would keep breaking down to the prime numbers and then look at them and say, okay, there's a pair of 5s. Anytime you see a pair under the radical, that's going to come out as just one whole number, because that's 5 times 5 is 25. There's your perfect square. 5 is the square root, and then the 2 is left over under the radical. So this would be my simplified radical, 5 radical 2.